Okay, part C, explain what is meant by the terms oxidizing agent and reducing agent, and illustrate your answer by predicting reactions from redox systems 1 to 6 in which chromium 3 plus it behaves as an oxidizing agent and as a reducing agent. Include overall equations and explain why you've made your predictions. State symbols are not required. This is a 6-mark question. This is on the old style of the papers before they brought the levelled response questions in. So this is 6 individual marking points, but this is quite easily something that could be transferred over to a level of response question where you're going to get your categoric marking. Okay, so take these questions bit by bit, making sure to treat each section here as a bullet point and answer them separately. Okay, that way you're going to avoid missing things out. Let's start off with the two terms, oxidizing agent and reducing agent. Okay, so I'm just going to put OA for short because I'm lazy. Oxidizing agent. Now be careful here. This would have been taught to you as the oxidizing agent is something that oxidizes something else. Okay, which it is, but that's not an in-depth enough explanation to describe what is meant by the term oxidizing agent. Okay, so think about what the term oxidizing means. Oxidizing means loss of electrons. Okay, so you could say the oxidizing agent causes something else to lose electrons or removes electrons from another species. Okay, so let's put this, just causes loss of electrons of another species or from another species. And the reducing agent, you could say, is the opposite. It causes the gain of electrons. On another species. Okay, there's a few different ways you could approach this. You could say the oxidizing agent removes or accepts or gains electrons or causes loss of electrons for another species. And the reducing agent, you could say the reducing adds or donates or loses electrons, or even you could talk in terms of oxidation number. You could say the oxidizing agent increases the oxidation number of another species, and vice versa for the reducing agent. Okay, but your first mark comes from a statement for both of these things here. All right, it's not one each, it's both of them. Okay, the second part of this question, illustrate your answer by predicting reactions from redox systems 1 to 6 in which chromium 3 ions behaves as an oxidizing agent. So if I bring this first answer, the first bit of the question back in again, it's this results table we're looking at, well, this table of electropotential we're looking at here. So you look for your, first of all, look for your chromium 3 ions. Okay, we've got a chromium 3 ion here in redox system 2, and we've got a chromium 3 ion here in redox system 5. All right, so when the equation is when the ion is on this side of the equation, you're looking at here, the chromium ion could act as an oxidizing agent because it could obviously be reduced in the process. And with the chromium ions over here, this is where it could act as the reducing agent and get oxidized in the process. So the comparisons then come from your electropotentials. You need to look here and compare the electropotentials with the other systems. So if I look between systems 1 and 2, we can see that the chromium half cell has got a more negative or less positive electropotential than the aluminium one has. Okay, so it's feasible then for the chromium 3 to reduce to chromium 2 and therefore cause the oxidation of aluminium to aluminium 3 plus. So there, the redox system between 1 and 2 would show the chromium ion acting as the oxidizing agent because it will reduce to chromium 2 and then oxidize aluminium to aluminium 3. So if we put that into an equation, the best way to do this, as we've said in lessons, is to put your more positive half cell equation on top. Okay, so the chromium system is 0.41 and then the aluminium system, Al3 plus 3E minus, gives you aluminium, and that is minus 1.66. So, as we can see here, because this one is more positive, okay, that's going to go forward. The electropotential being more positive indicates it's more likely for the chromium 3 to reduce to chromium 2 and therefore cause the oxidation of aluminium to aluminium 3. So you combine an equation then. Obviously, first of all, equalize out the number of electrons. So you'd need to multiply the chromium equation by 3. So your overall equation for this first one is aluminium plus chromium 3, 3 chromium 3, sorry, because you multiplied the equation by 3, will produce the aluminium 3 plus ion plus 3 Cr2 plus. And there we have, you can see the chromium here is acting as the oxidizing agent, all right, because the aluminium is being oxidized to Al3 plus. So you'd say the chromium 3 plus is acting as an oxidizing agent because it has a more positive electrode potential. So any explanations to do with the feasibility of reactions, you talk in terms of more or less positive or more or less negative. Avoid saying bigger and smaller, because that could be misunderstood in terms of, well, does bigger mean more negative or does bigger mean more positive? So try and refer to any electrode potentials when you're comparing them in terms of positivity, more positive or less positive, rather than bigger or smaller or larger or greater. Okay. So here is the best explanation you can give for this first bit. The chromium 3 plus is acting as the oxidizing agent because it has a more positive electrode potential than the aluminium half cell. Okay, so now we need to look at one where the chromium is acting as a reducing agent. All right, so if you can bring your table back in, you want something that's going to allow the chromium therefore to oxidize. So this time you want to combine systems 5 and 6. Because the bottom system here has got the more positive electrode potential, so that's going to go forward, that reaction will go forward. So the iron oxide ion here is going to reduce to iron 3, causing the chromium 3 to oxidize to the dichromate ion. So here, the chromium 3 will be the reducing agent because it's causing the reduction of the FeO4 2- to iron 3. So, the final part of this answer, move that up a little bit. You're going to be comparing redox systems 5 and 6, but the more positive one on the top, which is the bottom system, is system 6, FeO4 2- plus 8H plus 3E- produces Fe3 plus and 4 waters. And that's got a redox electrode potential of 2.20. And then the chromium system, Cr2O72- plus 14H plus 6 electrons will produce the chromium 3 ion plus 7 waters. And that's got an electrode potential of plus 1.33. So in this case, because system 6 is more positive, system 6 will go forward. So this FeO4 2- ion is reducing to iron 3, causing the oxidation of chromium 3 to the dichromate ion. So in terms of the question, you can see here the chromium 3 then is causing the reduction of the FeO4 to Fe3 plus. The chromium 3 is acting as the reducing agent. So the overall equation here, again, equalize out your electrons. So we've got 3 electrons in the first equation, 6 in the second one. So if I multiply this equation by 2, that will allow me to equalize the electrons out and balance the charges. So the overall equation is going to be 2 FeO4 2- plus 2 Cr3 plus. So remember, opposite ends, plus 8H plus. Electrons will cancel. Will produce 2 Fe3 plus 8 waters plus Cr2O72- plus 14H plus. So now I've got hydrogen ions on each side. I can cancel these down, so I can remove the 8H plus from this side and take 8 off of there. So that will completely be removed. Let's rub that out. Take away 8 from this, and that's going to give me 6 hydrogen ions left over. And there we go. So the same explanation this time. You could say that the chromium 3 plus ion is acting as the reducing agent because it has a less positive electropotential. There we go. There's that question answered. So marks, 1 mark for the oxidizing agent, reducing agent. Second mark then would be in the first equation, the chromium reacts to the oxidizing agent and the equation. So so all of this here is for your second mark. Okay. Third mark is going to be chromium reduces the Fe4 minus. So you could make it so third mark for this statement here, fourth mark for the equation. So they're giving you a mark for that one because it must be more difficult to do because you're having to do a bit more work. And then the final mark is going to be, that's 1, 2, 3, 4. Just checking the mark scheme here to see where those marks are coming from. I can't see the 6 marks there. 1, 2, 3, 4, 5, 6. Oh, there they are. Sorry, just checking the mark scheme again. So the final marks are coming from here. So stating the more positive electropotential for this one, explaining why chromium has is the oxidizing agent. So 1, 2, 3, 4, 5, and the same here. That statement there is indicating the final mark.